Hey, this is Mr. Vale's math class, and today we're going to talk about equivalent fractions. And if you want to check out part 1, it's right here, but if you're all ready to go, let's get started. Last time we talked about finding equivalent fractions with pictures and thinking more of like what a fraction looks like. Today we're going to use a method that involves multiplication. So to start out, we're going to work with 2/3. And if you remember, that means the fraction we're working with, the name is thirds, and we have 2 of them. So if I was going to represent that with a picture, I have 3 parts. I split this one circle into 3 parts, and I shade in 2 of them to represent 2/3, or 2 out of 3. So now what we're going to do is we're going to use multiplication to find an equivalent fraction. And how that works is we'll multiply the top number and the bottom number by the same thing. So when I multiply 2 by 3, I get 6. And when I multiply 3 and 3, I get 9. So 2/3 is equal to 6/9. And here's a couple reasons that works. The first one is the multiplication reason. So 3/3, or the fraction 3/3, is equal to what number? Yeah, it's equal to 1, because 3/3 is 1 whole. When we multiply something by 1, like if I do 4 times 1, well, that's equal to 4, or the number stays the same value. Same thing happens with fractions, but when we do it in this different form, the numbers representing the fraction changes, but the value of the fraction itself does not change. Now, the way I can show this with this picture is, well, when I multiply 2/3 by 3/3, I'm splitting each one of these 3 pieces into 3 parts. So I got this one being split into 3 parts, this one being split into 3 parts, and this one being split into 3 parts. Because it's like that doesn't work, too hot. So I'm splitting up these 3 pieces into 3 pieces to create 9 pieces. So now my new fraction name is 9ths, or if I count these up, there'd be 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the 2 pieces that are shaded in are also getting split into 3 pieces each to make 6 new shaded pieces. So this one piece became 3 new pieces. So 1, 2, 3, and then 4, 5, 6. So that's a couple reasons why to show that this multiplication method works. So let's say I want to do this with a different fraction. Well, I can take 2/7 and multiply it with 10/10. And what will happen is 2 times 10 is 20, 7 times 10 is 70, and 20/70ths, that's a tough one, will be equivalent to 2/7. Now we can also do this with, let's say we have 2/5 as something over 10, or like 2/5 is blank tenths. Well, I know that 5 times 2 is 10, so if I also multiply that 2 up there by 2, then I know that 2/5 is the same as 4/10, because 2 times 2 is 4. And likewise, if the bottom part is missing, and I'm like, well, let's see, so 6/8 is equivalent to 30 over what? Or 30 blanks. Well, 6 times what is 30? Oh, 6 times 5. So then 8 times 5 will give us the denominator of that fraction, or the bottom. So 8 times 5 is 40. So 6/8 is equivalent to 30/40. Now, a situation you could think of is, let's say, like, for every 8 pizzas, 6 of them are cheese. So then if I had 40 pizzas, 30 of those would be cheese pizzas. So these equivalent fractions, they keep the same ratio, or the fraction has the same ratio or the same relationship, or what they'll say is the same value, but it's just represented with different numbers. Yeah, that's some more stuff about equivalent fractions. Today we went up and went from like 2/5 to 4/10. Sometimes they'll even go down. So like they'd be like, oh, 4/10, we can do what's called reduce that to an equivalent fraction and reduce 4/10 to 2/5. Hey, I hope that helped out, and feel free to check out some of the other fraction videos and give us a subscribe and stuff. Okay, thanks guys. Bye.
In Mr. Vale's class.
Very nice.